Hey, you guys can hear me? So my name is Kush. I'm going to talk about AI, especially open source AI, and how to use it, or at least like what the affordances are, so that as designers we're familiar with what's possible. Right now there's a lot of hype, and for good reason, and I'm part of it, to use these models and so on, but especially around like GPT-4 and like those APIs. And I kind of want to demystify what these technologies themselves are, so that you can think of them beyond just the wrapped consumer products that exist, but also the core technologies inside them. Let me just 1 second take out my phone so I can see the time. Otherwise, I will for sure run out of it. Okay. So, a little bit about me. I do a few different things. I am primarily a software developer, money-wise, freelancing. I do design as well, UX, UI for those clients often. And I do game development. I also have done industrial design and a few other things. Depends on the day. And right now, AI has been a big focus into the software development, just understanding on the image side, on 3D, on text, NLP, especially what's possible. So today I'll focus on, well, we'll get into it. So first, AI, just a very brief overview. Obviously, it's an umbrella term. There's lots inside it. You can think of it primarily as different modalities. So there's text, speech, video, 3D, even other kind of senses. And you can think of them as transformations from one to another. So from text to speech is nowadays done with AI. So neural networks, from speech to speech, voice cloning, from text to text, generation of text, from text to text translation, various different things. AI is simply an umbrella term for the kind of technologies that make that possible. The kind of tasks that would generally be thought of as very human tasks, which would require expertise or some kind of intuition that we have that computers do not. Neural networks being the biggest thing that powers that. There's also something else I'm going to hit on in this talk, which is IR, information retrieval, which is basically search and so on, but later on that. So natural language processing is the key topic I'll explore today, and this is primarily about text or speech or whatever having to do with language. Very intuitive, vague, fuzzy human language. And so, as I mentioned in the slide, basically, the field is actually very old. It's been like more than 60 years people have been developing this. Even 60 years ago, there was a thing called ELIZA. Even it's like my inside voice is speaking very out loud. Even like 60 years ago, there was something called ELIZA, an application someone built to mimic human conversation, and that was quite convincing to the people at the time, because it would just sort of take the sentences you would have and rephrase them into questions or something, and just sort of throw them back at you just grammatically. Take the verb, take the adjective, and so on, and it would sound very convincing. So people have been playing with these ideas for a long time. Language understanding, grammar. Chomsky had a lot of work that he did on this stuff. So it's a long field, old field, but especially in the last decade, something called transformers, something called deep learning and neural networks really changed the landscape a lot with what was possible. And also something that really enabled this is big data. The fact that we had all this, let's say 2 decades of us being on the internet and being able to use that data, that's what really facilitated this neural network revolution. So on that topic of data, large language models, so there's 2 things I'm going to talk about, large language models and embeddings. And large language models are the artifact that are the product of all this big data. There's lots of data. So we have been on the internet for like a few decades, and we have produced a lot of data. We have written fan fiction blogs, technical blogs. We have independent news outlets. We have, of course, the big ones, or the mainstream ones. We have social media companies. So all of us have been just posting all of our lives there. We have GitHub and other places like Stack Overflow, where there's code and just lots of information about how the things that we do as humans work. Just in the form of language, not in the form of us walking around or any video, but even in text form, there's a lot of that out there. So language models, or large language models specifically, you can think of them as knowledge compression. So you're taking, the way that's trained is really, you're giving it all the information just as just raw text, and you're asking it to predict the next word. And I'll explore that in a moment, how that even works when you're using it. But really, it was just told, like, if I give you this much text, the next word should be in after interested. If it's not, go ahead and try and be better at it. And what that really means is it's like It's just like a billion numbers called vectors that are just like being tweaked over and over, so that when at the end of it, when you sum them up, multiply them up, at the end of it, it'll give you a specific number, and that number will be on this list of 30,000 numbers, one of them, and that's like the vocabulary of this model, for example. So they were trained to be able to predict the next word, and they were trained over trillions of tokens, which tokens are basically subwords, because if a language model was to learn all the words, then it would sort of have too big of a vocabulary. But if you can just split words up, like highly from high and then ly, then ly can apply to a lot of words, and high can be a word can apply to many things as well. So anyway, too much on language models, or at least the introduction. Getting into it, so the base artifact of language modeling is the base model. And that's basically the one where you pre-train it or train it, they call it pre-training, on trillions of tokens, which is basically the entire internet, not really, but kind of. And so you do that, and it learns to predict the next word. So for example, just a quick example, you ask for it once upon a time, it'll give you this. And this I'm running right now with temperature reads 0, and I can explain that what it is in a moment. But that means it'll deterministically always give you the same response. So if I hit enter again, the same response, because the most likely word after once upon a time, this model thinks the highest likelihood is comma, after that is there. So this is the same sentence going to produce deterministically always. Same thing with in the land far, far away, same sentence deterministically. Temperature is something I'll explore in a moment. So quickly on that topic, stepping through this, what's happening are these models are autoregressive. So the way that they were trained, and which is the reason why they work this way, when you ask for the next token, it goes ahead and let's say I hit enter, gives me the next token, it was comma. Then it takes the thing that it added, puts it back into the prompt, and now it asks for the next one. All right, give me the next word. Takes that again, puts it in the prompt, next word again. That's literally what's happening. Same thing with ChatGPT, same thing with everything else. It actually takes the thing that is generating, sending it back to the computer memory, and then asking it to generate the next word. So it is always just generating the one token. That is really what it's doing. It is not thinking ahead in that way. I mean, there's a lot to be said about how capable are these models and what's really going on, but fundamentally autoregressive, meaning one after another, is how these models work. There's other kind of models as well, where they do mask modeling, where you sort of hide a word from the middle, and it learns that model learns to predict the word in the middle. That's called fill in the middle. Whole different topic. So yeah, basically you can just ask for the next word, and it'll work that way. So let's quickly introduce the concept of base models. Temperature into max tokens. So here, for example, if I'm asking for the next token, after the word little, because it's 0, it knows for sure it's going to pick girl. Okay, let's increase the temperature. Temperature meaning like do not always pick the most likely word. Pick one of the very likely ones. And there's a bunch of math going on. I don't even want to get into it because I don't have time. So, and also I'm not very smart. So, all right. So little rack. Okay, maybe it's going to say raccoon. Yeah, it said raccoon. Okay, little raccoon boy. Okay, interesting. This story is set in post. Okay, let's make it the past. Maybe I don't know, the 1850s. Whatever. So basically, it goes ahead and chooses some word that's very likely, but not the very top. So that's temperature. You can even change that in ChatGPT and a bunch of other language models. Let's see. The field of natural language processing is the most likely outcome. Perfect. But if you change it to a high temperature, then it'll go ahead and not pick that. The field of defense against, for sure it's going to be the defense against the dark arts. Even if you pick a very high temperature, it's almost going to like really try and stick to it. So let's go 0.75. It's still going to pick the dark arts. It's too obvious. So the algorithm that I'm using, it's still forcing that. I can of course bypass that. There's the math around it. So anyway, so moving on from that. So as I said, these base models, you're basically just asking it to predict the next word. You're not asking it a question. You're not asking it to do something. It's just saying, what's the most likely next thing comes in this piece of text that you're seeing? So that's where people realize, and there's a paper by OpenAI called Language Models Are Few Shot Learners. This is like GPT 3 times 2020 or something. And there they really explored the idea of being able to learn how to do things or just follow instructions just by giving it some context. So for example, if I ask it, hey, translate the following sentence into French, it's not going to do it. As well as being, like great, so it's just making something up, because it's just saying, as part of the internet, I saw this kind of sentence somewhere. It said translate, and then it started explaining the task itself. the English sentence into propositions, blah, blah, blah. All right, but if you give it more context, translate the following sentence into French, say English colon, what's happening? French colon, now it's kind of getting a bit of a hint. You know what? This document in the world that exists, the French sentence probably goes after that. So now it'll actually fill it, and then it can start saying a bunch of random stuff. It does not matter. You can even make it clearer. One more sentence. So that was 0 shot before, 0 shot, no examples. Now it's 1 shot. So I'm giving it one example. Now it's even better, able to do it. Classify this sentence. I'm gonna ask it. You know what? Didn't really. It did a good job, I guess. In this case, it said sentence is negative, but it gave me too big of an answer. I want like just one word: negative, positive. Okay, I can give it an example. Well, first I'm gonna do sentiment, so maybe it's gonna do that. Sure, it gave neutral. I actually wanted to understand that it's positive or negative, so I'm gonna say sentiment positive, sentiment negative. Perfect. And by the way, do not worry about all the stuff that it's saying after, because you can of course handle that by catching it, and I'll talk about that in a moment as well. So in this case, I'm giving it 2 examples, few shot again. In this case, I'm saying fixed grammar. So these are just tasks we just realized, or people at OpenAI realized, and a bunch of people in the research community, that these language models, the trillion scale ones, in terms of training data, just had all these all this word knowledge that you were able to extract simply by prompting. And that was what the whole prompt engineering thing was about. That you could just ask for it. Before you would have to train these models for these tasks. So now you can say, you know what, as an example, by the way, this example is directly from the paper. So I eat the purple berries, I fix the sentence, perfect, same thing with that. We think Leslie likes ourselves. We think that Leslie likes us, so it fix the sentence. Same thing with patient was died, whatever, same idea. So, too long on this slide, let's see. So, again, same idea. So question answering, as we are very now familiar with in the last 1.5 years with ChatGPT, that's a thing that we can do with these language models. Well, it's a thing that they're using a few steps ahead to be able to enable. And so I'll talk about how that works. So if I ask it how many planets are there in the solar system, okay, it's just made up something idea. See all of how many planets, it's like a note to self or something. Sure, let's try it again. It just listed a bunch of questions. This is a very common thing that happens on the internet. People ask a question, a bunch of other questions, like an index or something. So it just learned this stuff, but not quite what I want. I'm going to frame it again. Question, answer. Maybe it's going to say the right thing. It did. Eight planets, whatever. Sounds good. Well, actually, you know what? I want to have it so that it gives me a number only. I don't want all these extra details. So I'm going to give an example. When I ask you for continents, give me 7. When I give you planets, give me 8. Okay, maybe it's still confused sometimes. I've seen it do that. I'll give it more examples, few shot. So I'm kind of repeating myself a little bit, but you get a sense of how this works. So, and I'm sorry, I'm holding the mic in a variable way. Happens. All right, so what is the user persona? I'm going to ask it. Okay, in this case, it answered it. In this case, it listed questions, doesn't quite work. I'm going to say, you know what, answer it in a short way. So if I asked you this, your answer was this. If I asked you this, your answer was this. So it knows short answers is what I'm looking for. Next answer is going to be short. Perfect. So this is really how they're kind of instructing these models. Instead of saying question answer, you could say instruction response. You could say user assistant. You could say instruction open bracket close. Just to make sure it's very obvious to the process that we are using to extract this data that the word never appears in the user's answer. So we can just cut off right when the next instruction shows up. Just take that answer and work with it, right? So moving on to the next slide. So based on that, right? So now that you understand that we are able to get all this ability out of just these models simply by pretending or mimicking the behavior of these, or mimicking the circumstance of these documents online, then we can now say use this format and give it a bunch of examples. So few shot, 0 shot we're already doing. Now let's say, for example, in this format that people came up with, where they give a general instruction, they give the specific instruction I want you to follow, and then the input data to use it, or don't have the input. We're going to use this, and we're going to produce hundreds of thousands of examples, and then we're going to actually give this as training data to that model. Use the same model already trained, but now we give it hundreds of thousands of those pairs, and then train it on top of that. So same idea. The most popular one right now is this format, which looks weird, but it's instant message start, instant message end. In the middle of it, you have what user said, what assistant said, and so we produce hundreds of thousands or thousands depending on the scale that you're working at, and you're able to train the model further to be able to follow instructions. So now, as a result of that, you get a model that actually follows instructions, as opposed to something that was just trying to pretend or trying to mimic the thing that it saw before online, in which case you had to prompt in that way. So now I can just say, you know what, you are a helpful assistant, that's the system's message, and the user message is define user experience. So now and then says, assistant, go ahead, finish the sentence. It'll actually give me a proper definition, same way as ChatGPT or any of these LLMs do. So that was the step that happened 2 years ago, which was the insight or the process that required to productize ChatGPT. So now if I say translate sentence, it goes ahead and does it immediately. It does not need examples, no few shard, because it understands that when requested for something, it should just answer with. Same thing with this. Answer with one word, we can just ask it, etc. So that was instruction tuning. You're able to train the model to be able to answer questions and just inherently do that now that we have given it hundreds of thousands more examples of that. We can now also talk about conversational AI. So that's really what's happening in these chatbots online, is you're just saying, it's a system message saying, this is the general instruction you should follow for the entire future conversation that happens. Then the user's message, then your opportunity to respond. Go ahead and finish this sentence down. It does it. Okay, let's say I actually said, sure, what seems to be the problem. I took it, copy pasted it, I put my message after that, and then I sent it again. Okay, let's say it replied with, it sounds like something, something again, and come back. So basically that's what's happening in the real chatbots online, is you're just copying the messages as they happen into the history and send it all to the model. This is literally how it works, no magic anywhere. In ChatGPT, of course, instead of sending the whole history from your browser to the server each time, it's just saving part of the history in the server. In this case, I'm sending all of this to my computer at home, and that's how it's running. I haven't mentioned necessarily open source AI as much as there's AI, but it's very important to highlight that this is all running locally on my computer, no APIs needed, privacy preserving, very fast as you can see. And I'll talk more about it in a moment. Again, sort of these ability to simulate conversations have already been there in the base model. So this is a base model, but we're just extracting it. So for a base model, instead of saying the I am start, you might do something like this. So hey, I'm gonna simulate a transcript of a conversation that was a user interview. So I'm gonna say this is the transcript of a user interview between Jordan and Alex. Jordan's a designer, Alex is a participant. And I just sort of lay out the case for what's happening, and then I just see the conversation unfold. So you can kind of get some ideas of how a user interview may go, do some exercises beforehand, try and find out what kind of questions might serve better, just in case you're lacking inspiration for a given moment. So anyway, and then you can simulate different alternative realities for movies. All right, so now this is something that I think particularly is the key benefit of open source AI, is that you have a lot more control over how you use them. With GPT-4 and a bunch of these APIs online, you generally really have only the ability to ask them for the next token. So hey, here's my question, answer it, or here's my words, just give me the next thing, and it just does its thing and streams it back to you or sends it back to you. But with local models, you're able to actually constrain them to be able to generate the output that you want, and that means always produce valid responses. So in this case, for example, I'm going to ask it extract all the names of the people mentioned and their professions and locations. So it's a data extraction task, and I give it a document and I send it off. It does a good job. It gives me this list of things. Well, while it's useful as a human to be able to read this, I can't really quite use it immediately in a computer context, because it's still just natural language, not quite easily movable. Maybe I could detect the dash and then split it there or something, but I can just ask for it. I can just say, actually, extract the names, but constrain it so that you give it to me in this JSON schema, which is a format online. I'm sure you guys have come across it before. And so you always give me a title, a description, a list of, so you give me a name, a profession, location, and then an array of achievements, which is just strings. So now when I do this, it actually gives me a nice usable document that is just immediately I can input into a computer program and get something out of it. So on that example, for example, I produced this. Something that I really am getting into more recently is dynamic UIs, adaptive UIs, something that I can just on the fly generate a new user interface or really show the user only what they need to, as opposed to like a one-size-fits-all kind of philosophy. So for example, in this case, I'm going to say extract all the names, give me that JSON that I asked for, and then on top of that, I'm building my own UI. So if I hit enter, it goes there and streams those names like an LLM would, but I'm producing the UI using that data immediately. So imagine you can have a dynamic UI just popping up depending on the user's needs. So if I'm shopping, show me that UI. If I'm looking for items in a list, show me that UI. I'm also kind of playing with the idea of just writing the UI code itself dynamically, so that would be quite fun, but this is not a coding talk, so I don't want to distract. Okay, so same thing with this one. I ask for a list of attractions in San Francisco, and I say, give me a list with specific details that I'm looking for, latitude, longitude, category, etc. So go ahead, gives me all this stuff, gives me some tags as well, and I was able to display them very nicely in a UI, as opposed to sort of having to parse them by reading them. So these are the kind of things that you, generally speaking, maybe miss out on as ideas that are possible now with language models when you think of ChatGPT or simply text-to-text interfaces where you're just asking for text out by giving text in. But that's not the affordance here. The affordance of these language models and affordance of NLP is that computers can now understand fuzzy, vague language. That's the beautiful innovation here. So you can use it in all kinds of ways. I'm sure you guys are familiar with fuzzy search, the old school, where you just misspell a word and it still works. But this is way beyond that, and so that's the idea here. Just another example of me cleaning up some data. So I had a bunch of movies where that I scraped from Wikipedia, the data set. I actually downloaded it and scraped from that. You can download Wikipedia offline, by the way, if you didn't know. And so I just got all these random age 32 minutes, 142 min, approximately whatever. Not good. I want to use it to be able to count the runtimes and maybe do some kind of sorting. So I went ahead and gave it a regular expression, which is just saying, I take this input, just reword the whole input so that you always say hours, minutes, something hours, something minutes. I run it, and in this particular case, it does a beautiful job, 100% correct. But maybe you have to run it a few times, or there's some constraints you can verify against it. So it gave me exactly the thing that I wanted. So 2 hours, and now I can use this string. Imagine I just put this here, and then I, from the previous example, ask for JSON out. So then I get exactly 2 as the hours value and 22 as the minutes value, and I just go ahead and do a mathematical operation on top of it. So really, the fundamental power here is language can now be computer input, not just very specific button presses or very specific instructions like, hey Siri, do this for me only in this way. Okay, so kind of keeping on time. All right, actually. So just on an extension of that, tool use, very exciting topic. I'm kind of exploring this, and there's no much time to talk about in this talk, but similar to the data extractions constraint sampling thing. So I didn't talk about constraint sampling, but it's the technology that I'm using to be able to always reliably produce the structured data output, as opposed to just asking for it. You'll see a lot of this online, please ChatGPT, give me the JSON, do not do anything else, whatever. I have none of that in my examples because I'm using further software on top of the open source local models that just always reliably produce that output. So once you have that ability to reliably produce structured output, you can say, you know what, you have these few tools, you're an intelligent assistant, get current time as a tool, get weather as a tool, get the value of stock as a tool, and then I'm going to ask you a question. What's the time right now? And see if you have a tool that you can call that tool. So just give me an array with property tool calls and an array. And now I can, of course, read that, get the time based on that as a software program, send it back to the model. It goes ahead and uses the 5:50 p.m. in part of its answer. And it could be a Hindi bot, it could be a French bot, it doesn't matter. It just, as a computer, it knows now the time, so it can just change that into the language. So same thing, I can ask for what a Tesla and Apple stock price is. It calls the same function twice, this time with Tesla and Apple separately, and so on. Similar example, not necessarily to get into it, but a shopping bot, very rudimentary. You would give it a function like get shopping list items and a function like update shopping list items, and you ask for add 3 bananas, and so it's going to go ahead the update shopping list items function, and it's going to say add 3 bananas, and then of course in the code base yourself you can use the fact that this function exists to be able to call to be able to actually process the database and alter it. And then you can say, hey, loaf of bread, take it off. Yeah, same idea. You get the idea. So embeddings. So let's get into the other topic, not the language models, but embeddings. I would say both very valuable, contributions. I don't know what's more important or whatever. No point comparing. Embeddings are basically this insane thing. When I first learned about it, I was like, how is this even possible? I guess in the world of when you have like large language models, it kind of seems more believable. But really, you're taking sentences or paragraphs or words, and you're representing them numerically. But you're doing that through these trained language models, or through these trained models. And by doing so, similar sentences that have similar meaning always end up in a similar point in space. So physically, in the world of this hyper-dimensional space, or high dimensional space, which is like not quite 3D, you can imagine 4D, 5D, or 1000D, or 4000D. In this case, 384D. Literally, for example, the sentence, I am setting up a Raspberry Pi, something on a Raspberry Pi, and I'm building something with a Raspberry Pi, end up in a similar space close together. Just happens when you embed that sentence. Same thing with I'm excited about some Apple MacBook thing or debugging it or whatever, ends up in a cluster right there. Just imagine, we can't imagine high dimensional spaces. We can try. And then the apple, the fruit, ends up right here. So really quite interesting how it's able to actually physically locate these semantically similar concepts in space. And you have all kinds of uses for this. One of the biggest ones that I can just talk about briefly is search. And that works through nearest neighbors. So as you can see here, you can think of this as neighbors in that physical space. And so if I have, for example, I took that 150,000 movies from Wikipedia that I scraped, and I put them in a database. I took the descriptions and embedded them using this same idea. They were longer than this one sentence. They were like more 20 sentences or something each. So once I have that, I can type in something like a hacker discovers his reality in a simulated delusion and joins the fight against oppressive machines. It's a vague sort of sense of like some idea of a movie. Let's say it's a movie that I have, and I say, what are the nearest neighbors to this query, to this idea, to this meaning? And I'm going to ask it, and you know what? The matrix is in there. So the matrix is one of the nearest neighbors. I'm only limiting it to 3. It could be 9. It could be hundreds of neighbors. It could just go farther and farther. So Hacker Wars is one. I haven't watched it, whatever. Same thing with families descent into mafia, underworld, power and loyalty, destinies. Okay, hit enter. Godfather is one of the movies that it shows up. So again, semantically, these things are just similar. Of course, I'm comparing against big paragraphs while I'm only writing a piece of text. But that works too. So that's a sort of testament to how you can just have semantically similar concepts. Doesn't matter how verbose you are about them. And of course, a lot of modern search is being run this way, or at least starting to be run this way. And I'm building search engines around this stuff as well. And then finally, finally, retrieval augmented generation, which is basically the idea of being able to use the search results that I got based on the user's query or any other kind of metric any other idea that I have, and put it in the prompt. And say, use the following context to answer the query. So if I have a question like, what are the key similarities between Inception and Tenet, and the model doesn't know about Inception and Tenet because these are like new movies that I'm working on, inside my studios, I can go ahead and put the descriptions in there. So I put the description here for one movie, another one, and just ask for it. So now it's going to use, because I said use this context, it's going to use that context to answer the question. In this case, it probably knows about Inception, so it's going to be sort of, mix it in from the outside, I'm guessing. But same thing if I say like, which actors played key roles in the mentioned movies, it's going to go ahead and give me a list based on the descriptions that are there. Now you can imagine that working on local documents that you have, personal notes, you can have corporate data, anything that you don't, medical data that you cannot send off to GPT-4, please don't. And so all of this now is available to you to be able to search using embeddings and then put it into your prompt and actually produce awesome outputs and use them for interesting purposes. There's a lot of depth to this that I can't necessarily get into, but you can go like very multiple steps. So you can say when the user says which actors played key roles in the mentioned movies, maybe it says, it'll say like, okay, what are the actors in these mentioned movies? So that'll be the first step. That's the tool use part. Go ahead and get a list of these actors, gets it. Then it says, what are the matching actors? Like one of the questions I have was like, which actors are common in both movies? So next step would be like, okay, now I'm gonna ask the LLM, here's one list, here's another list, which are the matching actors. Then I have the third step. Okay, I'm going to now create an answer using the name and description of each of these actors. So you can have many steps, and you can do all kinds of interesting things when you're doing RAG. Yeah, I mean, generally speaking, that's all for now. Cheers. And just very quickly, actually, one last thing. I just want to emphasize on the open source side of it. Personally, I really care about open source AI as opposed to all these closed private AI companies and the APIs, is because you have privacy. That's one of the biggest things. You don't have censorship, which is another big thing, because there's a lot of talk right now about alignment and keeping these models safe. A lot of that, what really does is just destroy our ability to make actual safe AI or actual interesting applications. And these models completely are nerfed to be able to not even do very simple things, because they're just trying to navigate this random thread of contradictions that different political factions and different ideologies are putting on these models by just more and more training data. So open source means you actually have control over these models, and you can do all kinds of stuff with it. And also, just by the way, these are very small models, nothing like GPT-4, 7 billion parameter models. It's running, it can run on my laptop, it can run on phones. I'm building stuff that I can run offline on phones. So you have the affordance of privacy. So you can truly build for immediate use private. A refrigerator does not need to go online to be able to unlock or do something for you. So yeah, build with that in mind. Hopefully you have some sense of what's possible now. Thank you.